Welcome to the Probability Podcast. Discussions on emerging and converging technologies, problems that are being solved, and the probability of positive and negative outcomes that we might expect. Now, please welcome your hosts, Jason, the generator Spracklin, and Patrick, the discriminator Lozon.
Hi, everyone. This week's topic on the Probability Podcast is the impact of AI on our planet. We will discuss monitoring of the environment, climate and weather modeling, and other ways it can affect our environment. We will also explore the possible negative impacts in terms of power consumption and how access and responsible use could impact income inequality and exploitation of disadvantaged populations. So, as the generator, I will pose the questions for this week's episode. What are the possible benefits of AI to our environment? What are the possible harms that it poses? And do they balance out, or are we at a deficit? What do you think, Patrick?
Well, there are many different benefits, of course, with AI, and I'll just start into some of these possible benefits. First off, if we just look at it as overall basic, capability of what AI can provide, it can help improve efficiencies, drive down waste, reduce fuel consumption and pollution. And that's just as a general scale. And you say, well, how can that be? That's through, controls. That's through monitoring and feedback mechanisms. That's through automation. Now, when you consider that, what are good examples? You got, any kind of situation where you're moving and transporting products and goods. You think about route planning. You think about the logistics around managing all the routes and the overall dispatching process and changing as you go. You also think about the different types of transportation. It could be waste collection or even people transit. Continuing down the vein of looking at general capabilities, look at how we create energy, how we manage power grids, how we balance out the demand on those grids, and consider supply versus demand on both sides of that equation. How we can integrate renewable and dynamic power sources that you see in, for instance, with windmills and solar power. They generate only at certain times, and then you have these peaks, and you have to manage that. And then how you integrate that into the overall power supply. So those are some brief examples. But when we think about what other further effects, let's go a little deeper, right? There are many cases we try to effectively monitor our wildlife and our flora and fauna, either through satellite or aerial imaging analysis, for instance, using drones and other aircraft. And we attempt to use these tools that we use on the imaging side to derive information. And that ability to process and analyze and come up with specifics around that information, through our observation, is not necessarily as keen as utilizing, an AI to process some of these images and come up with, tracking, for instance, biodiversity trends and that kind of thing. So yes, we can help with, managing wildlife. We can help with air and water quality monitoring, controlling water and, for instance, treatment systems, managing pollution and removing that pollution. We can improve building materials through the process of refinement and research. Um, Also introduce new designs. Also, a big part of this is the process of building can be improved, which leads to less cost there, less labor, higher efficiencies, less time. Um, and of course, we think about the idea of ultimately about reducing the carbon footprint of all these activities. Um, that being, the creation of waste from the point of view of carbon dioxide and that kind of thing.
Hmm.
So that leads into waste and pollution management, right? Um, what can we do to improve that, right? Uh, from a point of view of uh, hard waste, our daily household waste and that kind of thing, you can have systems that, through their imaging and such, can help with intelligent sorting, uh, waste risk prediction and forecasting, um, conversion and recycling, landfill utilization and reduction, and even hazardous waste management, compliance monitoring, and even if you consider maintaining all that equipment that's involved. So incredible gains there on waste management and improving our systems around that.
Yeah,
They
so as part of it, sort of looking at AI or technology as a tool to
exactly,
empower people in those industries. So for example, there's not a huge number of people involved in those activities as far as professionals, scientists, those type of people,
yeah,
and
it's not all just scientists, right? We're talking about implementing systems to,
mhm.
and we're company solutions, right? So a company produces a better mouse trap, so to speak, and gets it out in the market and that mouse trap integrates AI capabilities to provide better service and so on. So that being said, let's think a little bit more about the higher picture about climate, right? When think about environment, the first thing that comes to mind is climate change and all that. So we have waste and pollution management, which is really the creation of CO2 and other forms of gases. And this is where I want to get into is CO2 is a primer, but then we have methane and we have nitrous oxide and other forms of gases, which are actually much worse from the point of view of forming we'll call it a heat condenser, a heat collector in our environment. And CO2 is just one of those, and its parts per million is very low in the overall atmosphere, compared to other gases such as methane. So we do have to jump on board onto researching mitigation, not only of CO2 but these other gases, and we have to do it quickly. Um, and there's not a lot of research. There's a lot more we need to do to investigate how we can remediate those types of gases. There's been some significant gains on CO2, um, how to leach that out of the atmosphere, and there's many different solutions out there today. But what can we utilize in a cost-effective manner and in a very efficient manner, considering we're talking about a very large expanse of our atmosphere, even though from the ISS, you take a look at those pictures, and the atmosphere is this tiny little blue band, that goes around the Earth,
Hmm.
right? But it's 10,000 plus feet high, and it's a considerable volume to think about. How can we actually affect that? How can we actually condition that to any scale? So there's a big question about what we can implement. to improve the atmosphere overall.
Well, and to monitor what's happening, right? There's this recent report around wildfires. They release 7 gigatons of carbon dioxide a year to the atmosphere, and now we sort of have wildfire season. It seems like every year we're seeing wildfires taking over different areas. You've just seen the devastation in Jasper, for example. And then oftentimes they're difficult to predict. I mean, and when you can't predict them, you can't control them as well as you should be able to. For example, right? The faster you get ahead of a wildfire from a firefighting point of view, the faster you can get it under control. So I think there's definitely some interesting angles there in terms of using AI to predict what's going to happen, right? So the idea is to get ahead of it and help prevent some of the damages from these things.
Exactly. I mean, we're living in a climate of extremes now. When you think about the climate change, first thing that comes to mind is, our ice is melting, right? That's the go-to, right? And even with ice melting, I mean, AI can help with the imaging and the forecasting of that, right? Of trends. I mean, we guess and we think we know what's happening, but until you get out there and measure and you utilize the tools to measure, some of them aerial tools as well, then you get a true appreciation of what's going on. And you think about, when these big ice shelves calve off, right? In the Antarctic, surrounding area there, those big we'll call them supermassive or mega icebergs, we'll call them. They'll float out to the southern part of the ocean and the Pacific and over the Atlantic, and they'll stay there and melt. And it may even take a decade for them to melt. So they don't instantly cap off and then go into the ocean and just disappear. It doesn't happen that way, right? And then you have this effect on these mega icebergs have effect on local currents, local temperatures around that area and the whole bit. So the idea of monitoring these activities from a more holistic point of view really can give us a better understanding of what's going on. Even on ground here, when we're looking at our watershed, it's very important to understand how water's flowing, flood prediction. What's the overall expected water supply. We have a lot of issues that are occurring today because we're living in this climate of extremes with drought, and whether or not we're going to have replacement of this groundwater or not, from a climate perspective and from a geological perspective. Lots of concerns around water quality, concerns about soil erosion and sedimation, and with that in mind, AI monitoring systems can help for us to understand these systems. I mean, imagine being able to upstream have a number of solutions out there that are monitoring sensors, and from that derive, okay, we're going to be hit with a flood, and it's going to be, these are the levels we're expecting, and we're able to move people out of the way quicker than what we do today. So then you get into being able to respond, right? The emergency response, and protecting people and their property. As well, when you think about what AI can do from a point of view of technology, our technology today, we have these big, monstrous data centers that are utilizing literally billions of gallons of water. They're generating, I don't know how many joules of heat. They've got, they're consuming incredible amounts of power. AI can certainly help with the design and improvements on that equipment to be more, to use less power, to generate less heat. Of course, there's this consideration that it was an interesting It's called the Jevons paradox. And what Jevons said was the more a resource becomes more efficient, the more it is used.
Hmm.
So,
Yeah.
when you think about it, sure, we can get more and more, efficient and use less and less power, but then you can get more and more units.
Yeah, people can get more out of it. I just saw an article talking about sort of investors, in this space in terms of tech investors and whatnot, investing in sort of the area of data centers and GPUs and all that sort of technology that's powering all these AI companies, and that by cornering the market on that, then they can now go invest in companies and offer them that capability. So I think what you're going to see is, yes, you'll see the ability to produce AI that's more efficient. We're seeing that trend towards smaller language models and that sort of thing. But then on the flip side, there's so much demand for it now that it doesn't mean that we're going to be using less overall. And in fact, there'd be probably even be more acceleration because the barrier to entry will be lower. And so AI can certainly help with how to improve on the amount of power that's being used, and we can use other tactics, but it doesn't seem like this train is slowing down anytime soon,
No,
as it were.
no, it's not. But I think you hit the nail on the head when you talk about, um, you know, other companies and other technologies coming out of this, right? Just like we've seen every time we've introduced a new technology, there's opportunity there, right? And these opportunities come out, and so just some jobs are going to come out of this in a positive manner, right? It's not all job loss, right? Um, and these new opportunities can create new companies, new industries, and in effect, uh, you know, basically migrate what there is today into different forms, right? So that's a positive thing. Um, Also, we need to look at other positive aspects that we're doing today, right? Um, for instance, there's the ocean cleanup that's being run to remove all the plastic, or I can't say all the plastic, but I'll try to remove some of the plastic in the oceans. We've all heard of the plastic islands floating around in the oceans. Can systems actually be utilized to, predict where they'll be? Can the equipment that we send out to collect all that, that debris, can it utilize AI to help and guide it and to grab and maximize the removal of that waste? And yes, the answer is yes. So Ocean Cleanup has a system too. They utilize a camera, a guidance system, and it optimizes, the collection of plastic debris. And they've also have similar systems that are running, that are at the head of rivers to attempt to stop it from going into the ocean, and eliminate the problem right at the beginning. And those systems are running today, and they're pulling out multiple thousands of tons of plastic and waste today, and that's great because that's not going into the environment. We got agrobots that have been developed and are in the process of being tested, that are traversing fields and identifying disease and infestation, and creating maps where you can focus in on corrective measures, so you can use less pesticide, right? And or less disease management, treatments. So that's cost efficiency, but that's also from a point of view of environmental sustainability. We're not utilizing that many more artificial agents and introduce them into the environment.
Mhm.
So I mean, these are great, great things that are on the way and coming in. And if you can, get yourself involved with any of these opportunities, there's a very good possibility they'll do very well. both financially, like economically, and also from the point of view of what they're going to do for
Yeah,
the
I think
environment.
there's a challenge out there with the environment as well, as far as data being sort of siloed, right? That there's
Yeah,
a lot of data being collected and cataloged by, different organizations that aren't necessarily connected. So that data is, a little bit difficult to access in the aggregate. So if by some means that can be utilized and examined by AI to come to some conclusions, we can look at things from more of a holistic planet view, for example, right? Like Microsoft has this Airband initiative working with global partners to bring internet access to more of the world, and by virtue of that, bringing in more data and trying to tie it all together, which I think is really important. And I guess that's sort of the end goal, right, with AI when it comes to the environment, sustainability, and trying to figure things out, is that, as we always talk about, there's its ability to take a large amount of data and crunch it and come to conclusions and give us insights is huge for sure, right?
yeah,
It's
that's right. Yeah, I'm really glad you brought that point up because when you think about sharing of data, right? What is proprietary and what is for public consumption? And a lot of companies they basically generate all this big data and they want to keep it to themselves, right? But when you think about the environment is global, right? And
mhm.
it really what we're talking about here is changes in perspective for the client, for the different customers, the clients that are utilizing this data, um, for the general good of our planet, right? Um, and sure, it costs money to collect this information, and I certainly understand the idea of protecting access rights to some of that. That's very expensive to collect, but the other side of this too is that there can be open, models, and there can be low entry fee to get hold of this information, and for other companies to take advantage of that information and then drive, initiatives forward from a point of view of improving our environment even further, right? You may have, let's say, I don't know, an oil and gas company, collecting information that's around atmospheric behavior and that kind of thing, or a certain area that they're exploring. That information can be conveyed to other companies, right? So this sharing of information is really, I think, critical in the future for us to move forward as from a larger point of view, right? You think about smart cities and their intent to share data on demographics and that kind of thing. It's very, very important ultimately when it comes to looking at the larger picture. So that's a good point when you think about it. Also, one of the key things I want to jump into on this thing is how AI is helping on the weather model side. Because if you think about environment, the first thing that comes to mind is the weather, right? Like I said, we're dealing with extremes. What can we do to help with that with our technology? And first off is weather prediction, right? That's one of our key challenges. We've been dealing with that challenge for for centuries now. How can we better predict? And the Farmer's Almanac is great, but it doesn't work at the at the granularity that we need day
Yeah.
in day out. So we have to employ uh, many different many different source systems out there, monitoring systems to help with collecting weather data. Right? It's not just the weather labs. We have satellite imagery. We've got Doppler radar. We've got weather balloons, and so on. And all that information is being collected continually, day in, day out. to help isolate what's happening at the time, right? And then you take that information and you can build models from the history that we know and try to predict what's going to happen next. And there's right now there's some systems out there that are they call numerical weather prediction models. The European Center for the Medium Range Weather Forecasts, for instance, they have basically a prediction forecasting tool, which is this, weather prediction model that is all calculations, and it takes. Well, it was a heck of an achievement, right, to build this out in the first place, to get an actual model that works as good as it does. But from a point of view of looking at, bigger data and then using that to model this history and then what's going to happen next, AI can really help with that. So if you kind of take away the calculation aspect of what these numerical models do, and you look at it from what an AI can do, an AI can generate, once it's done all this training, it can generate a prediction with a lot, higher degree of efficiency and a lot less resources, a lot less time. So, something that may take hours to generate from a point of view of forecast can take minutes, and it can be just as accurate or even more accurate. And if you look at what the testing that has been done to date on these models, their accuracy is very high. With that in mind, there is a caveat to that, and that is the AI model's ability to predict the unusual, right? The extremes. Because they work in these normalized models of expectation, and then when something extreme happens, it's not part of the normal expected data set. So, with that in mind, can you build models, AI models, to enhance that and improve in that? Yes, that can be done, and that's part of the evolution of these systems, right? However, that's just kind of the caveats of what we're seeing today. And these systems, they do all this deep learning. What does that mean from a point of view of something new and novel that they can produce through their forecast that, our existing forecasting models would miss, right? So there's some interesting learning that we still need to look at. Now, what kind of models are we looking at? There's the Pangu weather. It's by Hawaii, that was released in 2023 of August, and it kind of set the stage for a lot of the AI weather models. And they were also testing alongside the European Center for Weather Forecasting, and that's where a lot of this initial energy came from to say, yeah, let's keep moving forward with this. Now there's multiple models out. The ForecastNet by NVIDIA, which is primarily focused on, we'll call it short to medium range. Now short range is like right now and today, right? Medium range is 7 to 15 days. And then you got the larger forecasting models.
It seems to be mostly what we have. Like when you go into your weather app, we've got
Exactly.
basically like a 14-day prediction. It won't really go beyond that, I'm assuming, because it can't really predict it with sort of any level of accuracy. I mean, even the 14 days is not always accurate, but at least it gives you a fairly good indication of what's coming in the next couple of weeks, for example.
Yeah. And if you think about the total number of variables at play over the course of 14 days for weather that is, whipping around the planet, that's a tall order, right? To be right on that, if you look out 14 days and actually be right on that day 14. So these models are continuing to grow and become, a little more accurate, with each day that we basically apply what we've learned, that weather that actually occurred, right? So with that in mind, we've got some tools that came out of our big, our big technology houses like Google, for instance, and Microsoft. So Google has something called GraphCast, and what's really interesting about that one is they pushed out this as an open source capability, and the idea is that with open source, you can introduce more rapid evolution and development of the product. Now it's proven that it can beat out the predictive systems, the existing predictive systems on a 10-day forecast, and the idea that they can predict the extreme weather is one that they're working on, and they're claiming that they can predict more extreme weather events when they occur, including hurricane, cyclone events, atmospheric rivers, which promote flooding events, any onset of extreme temperatures, that kind of thing. So with that, these models are continuing to evolve, and they're basically merging the technologies of what we have today with AI with the calculation models and the physics modeling models that pull in gravity, thermodynamics, fluid dynamics, all that, and they're actually this hybrid approach, a hybrid tool, is starting to get developed, which in essence is an incredible, you're stepping into a new area of AI development where these you can utilize not only the historic training, but what's occurring today, what's occurring now, and integrate that information to build out a forecast and a prediction. The other side of this is the Microsoft Aurora product. Again, it's more locked down from a corporate perspective, but they also claim to have the ability to forecast in a high degree of accuracy, wind currents, air pollution levels, greenhouse gas concentrations, and deal with variable levels of what we call fidelity, so they can focus in on some very small areas and go to wider areas.
Mm-hmm.
So
I think that's kind of interesting. Yeah. Like the Microsoft model veering into the idea of air pollution levels and greenhouse gas concentrations, because weather is one thing, right? And there's always this sort of debate around climate change, and a talking point is oftentimes that there's a difference between weather and climate being the more longer term look at how it impacts our planet and so on. So I think that's definitely an interesting area which AI can help, because we've been collecting data for a long time. I remember, over a decade ago, going listening to David Suzuki speak that, scientists have been sounding the warning bell since the 70s, when really they didn't have a lot of technology and a lot of access to data, but they could see those trends happening. And I think oftentimes people, they don't necessarily believe it unless there's a lot of proof as far as what's happening. And I think that's where AI gets kind of interesting, being able to take data from decades and kind of look at patterns and trends and kind of look into the future and say, well, this is actually where things are going. Now, of course, we're seeing extreme weather right now. And, in some cases, climate can be cyclical, can come back around in different ways. But certainly with this idea of predictive modeling, not just on like the weather itself, but on the longer term, climate, I think is important. For example, the IPCC reported that we must reduce global emissions by 43% by 2030. that's a pretty tall order. And given the current, sort of political climates and the willingness to make changes and how much you have lobbyists from oil and gas and these types of things, 43% is a pretty aggressive target. It seems like, and are people going to adhere to that if they don't believe in what's going to happen? And how can we attack this problem in a responsible way that also takes into account that we had to find a balance between the environment and the economy. But ultimately, if we don't have an environment, we won't really have an economy, or in a sense, there's the financial impact of extreme weather is huge, right? Whether you're talking
Yeah.
about flooding or fires, we just experienced a ton of flooding here in my city, and every day I go for a walk, I see people's basements emptied out into their front lawn, type thing. And that's certainly a cost at a smaller scale, but there's a huge cost to the environment. So while, it's interesting to look at it from a weather point of view, I think the climate area is important as well. And there's other smart technologies, smart cities, looking at how we're using electricity, looking at how we're monitoring, traffic and movement of goods. Road transportation emits 12% of global greenhouse gas emissions. How can we improve that? It's very difficult to build new roads, but how can we, well, not difficult, but certainly expensive. And, how can we figure that out, utilizing AI and technology? I think it's an interesting challenge. I was curious about your thoughts on sort of AI and the ability to sort of help us understand climate change and sort of get ahead of it.
Well, it's like you said, the climate is considered this massive thing, right? That goes over time, and it's global, and there's a big question mark about whether we really understand it and all the different variables at play. One volcano going off and on the ring of fire can change and actually lever a lot of the different models out there, and change the whole pattern, right? But we think about the idea too. I want to go back to what you stated before. We talked about wildfires, right? Wildfires are kind of a downstream response to drought, weather pattern, very dry weather, high winds, that kind of thing. And then you have maybe a lightning storm or some reason why it catch on fire. That fire now started. It's very difficult to stop, and you lose millions of hectares over the course of all the different countries. I mean, you think about what happened in Hawaii last year, Jasper just recently. It's formal weather, really, you think about it.
Mm-hmm.
These are extreme issues. And if you think about climate, take a bigger perspective and think about climate as, is this region, next year, is it going to be drought, high risk conditions or not, right? Or is it not going to be that? Are we, are there going to be, is it going to be very wet, right?
Yeah.
Those,
there are patterns as
yeah,
well, right? There are patterns to all of this. In fact,
there
we got
is.
to the point where we're calling it fire season or flooding season, right? That people know that a certain time of year, we've got a certain type of conditions that, it's fire now. So instead of it being, just the four seasons, fall, winter, summer, and spring, now we have fire season and other seasons, which is an interesting conundrum we're in that, we've seen fires throughout history, but now we're seeing them on a regular pattern. So I think this ability for AI to look at the patterns of things, not just in the, in the microcosm, but in the macro, and help us understand things and put data in front of us and saying, look, this is what you haven't seen, over the last 30 or 40 years. Here's the pattern that's happening. Here's the acceleration, and you can track it. And here's how, you're contributing to it as humans. Then we can alter some of our behavior and get ahead of it. It may be that climate is a steamroller moving forward, but certainly the evidence suggests that we can kind of slow some of this stuff and actually create a more habitable planet.
Well, there's
through our
definitely
efforts.
some possibilities there. I mean, like I said before, when we're looking at climate, there are very large models, but if you can consider AI is very good at breaking down the patterns, like you said, in AI, in large model data sets, right? And get them down to these weighted models that can be used to generate prediction, right? Or accurate prediction. So the idea here is that we have now a tool that we can utilize against these massive data sets and to shrink it all down into something that we can understand, right? And come up with some, valuable insights, right? And then we can utilize those valuable insights and prepare, right? Now, what can you do to prepare when we're thinking about, fires? Um, there's, I would say that that whole process of is open to opportunity. If you want to be serious about, protecting your hardwood, softwood industry, if you want to think about the ecology and the environment, um, better methods, right, for managing, wildfires and helping the process of stopping or hindering fires from starting in the first place. We've been working with this problem forever, but maybe we can also come through with some new and wonderful capabilities and ideas with help with these tools, right? Um, and with that, that can also save lives, right? Ultimately, so lots of positives when it comes to these weather models, right?
Hmm.
Basically, utilizing these decades, literally, I think the Google model used, I think it was 40 years worth of history, right? And to build these massive data sets and churn through them and determine, uh, you know, uh, we'll call them local region patterns. That's an incredible capability there. And then come up with predictions that are reasonably accurate, right? That's that's uh, that's a challenge that we've been dealing with, and I think AI is going to make it even that much more, uh, capable. We are going to hit a higher level of accuracy.
Hmm.
Um, Now, the idea too is the technologies that are being used are not just restricted to, the standard neural net models. We're looking at convolutional and recurrent neural nets and all that kind of thing. I don't want to get into the technology thing, but the idea being that there's lots of learning to be done just in the pursuit, right? In the pursuit of improving the weather model. And by doing that, um, you're in turn, uh, you know, taking information now that can be transferred to other areas of learning, right?
Hmm.
So this is part of, we'll call it the next generation of transformation, right? The next epoch in human history, right? To take all this learning and, compound it. Um, so, we think about other predictive models too at work, not just weather, right? We can use agricultural data, of all different types of agriculture data, not just the weather, and predict harvests, right? We can use ecological data of all different sources to predict uh, events, deforestation, that kind of thing, but also um, to help manage biodiversity. And, if we have specific types of high risk extinction events on certain species, we can help manage that and drop that risk. Um, and through that, we can also, build up responses, right? Um, these modeling and these trends can help us understand, what's going on with the environment, but that desertification, which is um, basically our deserts taking over through drought, and um, just better manage our environment, make better decisions, right, on how to manage and plan for the future. We can also utilize this technology to isolate events that occur in areas that are normally are not easily reachable, right? You think of a pipeline, that we built, 30 years ago, going through remote areas, hardly anyone visits, right? But that pipeline is critical to supply, energy supply. And it, you know, basically it develops a small leak, right? A small leak can turn into a lake, right, of oil, for instance,
Oh,
in a
absolutely.
very small time. Um, we can use the imaging systems, with AI to isolate when something is started, right? Not wait till it's a huge environmental mess that we have to clean up. Um, and we talked about, introduction of the ability to isolate certain events that would raise risk in wildfire. Well, what about, the sources of wildfire? Is there something along that line that we can track? Um, so there's many different models out there that are being introduced across the board in many different business sectors and industry sectors, and all those modeling and predictive tools are going to make our life easier from the point of view of being able to reduce the total amount of investment of energy, and also improve accuracy and that kind of thing.
Well, yeah. So, I mean, when we talk about all these positive aspects and things that we can accomplish, it doesn't come without a cost, right? And that's sort of the underlying, I guess, the elephant in the room, I suppose, that we've seen now that AI is a pretty power hungry resource, and there's a huge amount of computing power needed. Although I think that tide is changing a little bit with some of these smaller models coming out overall, but they still sort of position that as, well, the smaller model is good for, basic things. The larger models are still needed for, well, probably a lot of the things we talked about today with predicting weather and that type of thing. I know I mentioned to you recently that, OpenAI, of course, the makers of ChatGPT, um, obviously a very successful company, but their cloud costs alone have been something like 4 billion a year, and their revenue at 3.4. So, I mean, they've had incentive to build these smaller models. You don't need a large language model to help you put together a recipe for dinner, for example, right? But everybody's sort of, killing a squirrel with a bazooka, as it were, right? That we don't need that much power for every day. So there's some nuances coming in, but curious as to your perspective on, obviously, some of your favorite aspects, or some of the doom and gloom aspect of where things can be headed, as far as, what is the impact on the other side? Obviously, a lot of positive impact, but where are we seeing some of those deficits right now?
Yeah, well, you brought up an interesting point, and it's very similar to like the .com side of things, right? But this is not a .com. But what we're dealing with is millions and billions of dollars being invested in the industry, right?
Mm-hmm.
Of AI, with lots of promises, right? Now everybody's painting the sky pink and saying this is all going to happen, and we're all going to make millions of dollars, and our line our pockets with gold, right? But the reality is that some companies are going to do very well, and there's going to be some investments that are going to go you know down into the dumpster, right? And people are going to lose money. So that is the other side of the coin. So there's a lot of hype going on with AI right now, and
Mm-hmm.
there's a lot of money getting thrown at it. And are you really going to make that back, right? By all these, investing so many dollars, are you really going to make that back? And I guess Jason, this goes back to you and I, our product thinking, right? Where's the value equation? Who's going to pay, right? Who's willing to pay for this product or service, and to help finance that, um, whatever that is, right? Um, and a lot of this has not been worked out yet. So we get into the challenges around having to define what these opportunities are in the market and whether or not we can jump on board and they're going to be successful. And I mean, everything's a risk at this point because it's so brand new, right? But that also leads to the idea that, these products are costing incredible amounts of money, and sooner or later somebody's got to pay the piper, and there's going to be some that are going to also benefit off this incredible investment. Um, the other side of the coin that we're talking about, the negative side of the coin, is um, you know basically promoting um, promoting these tools to get larger, bigger, faster. Um, if you put it in a perspective of what we're dealing with, I think there was I read a situation here where Chat GPT currently consuming the equivalent energy of 33,000 homes, and every web inquiry is 4 to 5 times more expensive in energy compared to the standard query. Now, take those numbers back, with a grain of salt, but the idea being that, there's now a new escalated, cost and information. And we have to really consider that when we're looking at what we're trying to do, what we're trying to attempt to do. So that's one thing. The other side of it is what can this tool, this AI tool, what kind of bad things could result from that. And one is we talked about a little bit about exploitation. Well, for instance, when we're looking at the mining industry, they've got they've got a very poor reputation of really, which are human rights violations in the industry over time. They've built that up, and the idea what further type of exploitation can happen of our planet, right? We're looking at industries as a whole that are profit based, and uh, climate be damned, or what have you. They're going to make their money, right? The idea that these products also, we'll think about the data centers and the AI supporting products, right? They all utilize critical rare minerals to construct these servers, right? So you got cobalt and lithium and tantalum, and they all very high cost of extraction. They're relatively rare, and with that in mind, that also drives a tremendous amount of resource intensive searching as well, and possible exploitation of certain areas. So generating lots of heat, consuming lots of water, lots of power, utilizing rare resources, and generating exotic waste, right? So we have to recycle all these used assets. Case in point, we're building all these later, data centers with using NVIDIA technology and other company technology as well, which is the GPU type of architecture. All those older servers now are being displaced, right? So we're basically sidelining equipment, and we have to the responsible thing is to environmentally recycle this equipment, right?
How do we get a handle on this? Like in terms of how do we get some controls around this so that we all know that, while capitalism can be a very positive thing, we have to consider that when left unchecked, it can turn into a negative thing, like we just talked about pretty quickly. So, what are the sort of the legislative controls, or how are we sort of tackling this to ensure that we stay on sort of the positive side of the fence when it comes to AI and the environment and everything else?
Well, I mean, that's a good question. I mean, we've talked about this a few times that um, our governments are that this is a role in the government as well as a role within the industry, right? To self manage this, but also to for our governments to step in because that's their role in a lot of ways, and introduce laws and legislation to support that. So, um, start with the larger Paris Agreement, the climate agreement. And a lot of that is driving down initiatives uh, to individual companies to, for the point of view of carbon neutral, um, and trying to support this, healthy, healthy to our climate, healthy to our environment initiative, right? Um, but also we can look at the EU. They put out the corporate sustainability reporting directive. We talked a little bit about data centers and their challenge to become more environmentally friendly. Um, this is really forcing their hand to do that. And a lot of data center operators are going to have to take very close attention to this very soon. Um, and, the idea of it's not just a uh, reporting tool where you just need to improve the granularity of your reporting. You're actually going to need to do something. You need to do something from the point of view of reducing, or managing your heat, managing your cooling, reducing consumption of water, reducing um, consumption of power, and also, deal with the recycling and the equipment side of things. That's specifically that language is talking about, these big data centers that are these large powerhouses or houses for AIs. Um, as well, the U.S. Securities and Exchange Commission is putting together a similar legislation, uh, the Canadian Net Zero Emissions Accountability Act, and the 2030 emissions reduction plan. There's a whole in Canada are all driving a lot of this change, and some of this is coming into law very soon, this year and next year timelines.
Yeah, no, I mean, government certainly plays a role. I mean, companies have to think about it within their own, boundaries as well and their own reputation, right? That you can act in a certain way, but it just takes one news story for a company's entire reputation, kind of to go down the drain. So I think it's an interesting angle on things about how AI can impact us in many different ways. Apparently, Canada just put forth the Artificial Intelligence and Data Act, and in fact, one of the first countries in the world to propose a law to regulate AI. So it's kind of interesting. Oftentimes, we're a little bit behind as a country, but it seems like we're sort of forward thinking, promoting the responsible design, development, and use of AI systems in Canada's private sector, with a focus on systems with the greatest impact on health, safety, and human rights. So I guess we kind of talked today about this idea of benefits to the environment and impacts to the environment, and then we sort of branched it out to talk about things like human rights and inequality. So it certainly seems like AI has its sort of tentacles very deep into everything right now, and certainly governments and companies are playing catch up in some cases, because it's like any new technology, there's an excitement around it and people just start pushing forward. But it's actually pretty great to see that there are governments and other entities, even some of the big tech companies, that are thinking about this in a responsible way, because I think they see that there are some dangers there along with the benefits, and that we need to sort of have some balance in things. So, just to bring it back to what we talked about, some of our main questions, what are the possible benefits to AI? We certainly covered a lot there, right? In the area of, science
a
and
lot. Yeah.
predictive models and weather and climate, in multiple different areas where there's a huge potential to bring benefits to humanity. On the flip side of that, obviously there's a huge cost in terms of, the amount of power it takes to generate, these algorithms and whatnot. Although I think that's the tide is starting to turn a little bit on that, because companies are realizing that it's not even a sustainable financial model, right? That you see a company like OpenAI that's essentially, I think the quote was that they're going to run out of money in 12 months, given their costs and computing power. So it becomes that thing where, even though there's sort of a problem there, it seems like the industry is starting to sort of self-correct to a point. So I think some of those harms could be mitigated, in terms of, the use of electricity and that type of thing. But, the harm in terms of, the social impact and inequality, I think really does come down to government. So I think that there's, a two-sided coin here, in that we talked a lot about the benefits, and in terms of the harm side, and, in our environment, there's certainly potential there, but it doesn't seem like that's come to some kind of culmination quite yet. So, I'm just curious about your perspective on, do you think things are balancing out right now? Are we at a deficit? Where do you think we stand right now in terms of, I guess I'm thinking more in terms of where things are sort of today, not where they're going to be. Are we seeing more positive than negative impacts on the environment and our planet? What do you think?
Yeah, that's a good question. I mean, if you consider all the different industries out there, they're all looking at, okay, how can we utilize AI better? And those industries are also, those particular companies are involved with, in some manner, looking at the environment as part of their overall umbrella of responsibilities, not just economics, right? I think there's incredible positive output to utilizing these AI tools. I think it's going to, in the end, I think the positive will completely overbalance the negative in this aspect. But we are at the very beginning, right? So I think we're going to go through a few bumps in the road, as we go down this journey, right?
Yeah, well, it's like I said earlier, quoting sort of David Suzuki, that, we always trying to balance the economy and the environment, but without the environment, there really is no economy. So let's try and remember that as we sort of plow forward into this new age.
Thank you for listening to the Probability Podcast. Please join us next time for more musings from the generator and the discriminator.